Okay, so I wanted to help you out with number 17. It says a body is thrown upwards with an initial speed of 20 meters per second, and it falls 100 meters. So I'll draw a picture over here. Now I want to also change the words a little bit. What I meant to say was the period here. Okay, this is for 16 and 17. I would say it rises up, comma, goes down, and eventually moves 100 meters, I'll say, eventually moves to a height that is 100 meters below its starting height. Starting height was where it was released, where it was launched with its initial speed. So 16 and 17, please change the words to read like this. Okay, it'll make more sense. So body is thrown up with an initial speed of 20 meters per second. So I'm going to draw like a cliff or something so that this makes sense. And here's a person here. This object is thrown up with an initial velocity, and it's going to slow down on the way up, turn around, move faster. Well, turn around and move down. Now, at that moment, it's at the same height it was released. I'm going to make that my y equals 0 meters. So that's my, I'll put my number line there on the side. So that's my 0. This is y in meters. That's position in meters. And then this thing's going to speed up faster and faster as it goes down. And it's going to eventually be, I'm going to draw it 100 meters below where it started. And on my diagram, I have down being positive. So I have a picture, and I have a number line attached to my picture. This is going to help a lot. So you'll need to do this on every problem. And these arrows represent velocity. My initial velocity is, if down is positive, my initial velocity is going to be in the negative direction, and it's going to be 20 meters per second. And this negative, in my case, means up because I made down positive. But at least my acceleration is also going to be positive. My acceleration is going to be 10 meters per second squared. And that's a positive direction because my acceleration is down. Okay? Now I'll go ahead and draw a velocity time graph. I'm not going to worry about a position time graph. I'm just going to draw velocity time and acceleration time. Okay? So there I am. First of all, put some units on there. Seconds, meter per second. Units are super cool for checking your work and trying to understand what it is you have just solved. Now, if my body is launched up, its initial velocity is going to be negative. And then the object is going to slow down while moving up. And my acceleration is positive. So my acceleration doesn't change. It's just the acceleration of gravity due to the Earth's gravity. So here's my object slowing down. That's because these velocity numbers get smaller, and they're negative numbers because my object's moving up and slowing down. And my object slows down because my accelerations are negative. My acceleration is positive 10. Then, when my object turns around and moves in the positive direction down, it's going to speed up because its acceleration and its velocity are in the same direction. So there I am, something like this, right? Now, I suppose you would want to realize that if I draw a dotted line going down here, this area here is going to be 10 times t1. So I'll just call this value t1. So 10 t1, right, has to equal 20 meters per second, because my change in velocity is a positive 20 meters per second. So my t1 has got to be 2 seconds. All right, so this is 2 seconds, and I'll just erase this. And I'll write 2 seconds here. Now, if you think about it logically, there's a moment in time when my displacement is 0. Now that would be the moment in time when my object, the change in position is 0. So when the ball is here and when the ball is here, or the body, whatever it is, its final position and initial position are identical. Thus, you subtract them and you get 0 for your change in position. So at 4 seconds, that has to be the case. So these two red areas have to be equal at 4 seconds. And that's going to be another change in velocity of 20 meters per second. Okay? So this will be 4 seconds here. Now, after 4 seconds, my object is falling below its original starting position. So the 100 meters that my object ends up is my final position minus my beginning position. So really, this trapezoid here is going to tell me my displacement of 100 meters. And that's the trick with this problem, is realizing that these two red triangles are equal when my object gets back to its original position. And my ending position minus my beginning position is going to be 100 meters. So this area here has to be 100 meters. So let's see if we can figure something out now. I'm going to draw that on a new page. And you've already done problems like this. It shouldn't be too bad. But I just want to clean it up so I have some space. So, again, we now have a velocity graph. And I'm just going to draw the trapezoid part. Okay, that looks like this. And I'm going to say this area is 100 meters. Let's see what I can figure out. This is the velocity line. And my acceleration graph has actually been identical the whole time. My acceleration graph has always looked like this. My acceleration never changed. My acceleration has just been 10 the whole time. So 10t, and I'm going to call this amount t now. 10t has to be my change in velocity, which means this height here has to be 10t. Now, if I go back, my initial velocity at that moment in time has to be 20 meters per second. My beginning velocity at time 0 is negative 20. Now the object's going down with a speed of 20 meters per second. So I need a 20 here. And I'm calling this value t. And I can use the area of a trapezoid, which is going to be the average of my velocities times my time. So 1/2 20 plus 10t times t, right? And I guess I'm going to have to distribute by 1/2 t. So that's going to be 10t plus 5t squared, right? And this has to be equal by 100. And I should try to rearrange it. I get 5t squared plus 10t minus 100 equals 0. And I'm going to divide everything by 5. I get t squared plus 2t minus 20 equals 0. And I'm going to hope that this is factorable. 5 and 4, that won't do it. So we're going to make them look factors for me. 20 is 10 and 2, 2 and 5. So that makes, I don't know if this is going to be factorable. Looks like it might not be. 4 and 5 aren't going to do it, because those aren't going to add 2 ever. So I think I'm out of luck. I think I'm going to have to use a quadratic equation here. Unless I'm wrong, it could be wrong. So you'll use a quadratic equation to find t. And once you find t, you'd be able to find out the actual velocity downward at t seconds. But that's how you would do it, and it's a pretty interesting problem, pretty difficult problem, and I hope you enjoyed it. Hope this helps. Have a good day. Thank you for watching.